look at a problem that my dad presented to me. I really liked it. It comes from the Ginzburg-Landau equation, and I thought about it a while, and I finally solved it, and I found out that it used the maximum principle. So I'll show it to you. Let epsilon be greater than 0, omega be a subset of R2, and g a function from d omega to a complex number such that the modulus of g is equal to 1. Let u be a function from omega to c, being at the same time a solution of this equation. Minus or plus u is equal to 1 over epsilon squared times u times 1 minus the modulus of u squared in omega, and u is equal to g on d omega. Show the modulus of u is less than or equal to 1. Solution. Now, the idea is to make an equation for the modulus of u squared minus 1. So, let v be defined as the modulus of u squared minus 1. Now, we know plus v minus, minus or plus v is equal to minus or plus u times u conjugate, which is equal to minus u times the plus u conjugate, which is the conjugate of the plus u, minus u conjugate times the plus u, minus 2 times gradient u dot gradient of u conjugate, which is the conjugate of gradient u. Now, using the equation here and here, you know that the plus u, all that conjugate is, well, this is real, so it comes out of the conjugate. And here you have a u conjugate. So with the u, you get modulus of u squared. And we get the same here. So this is 2 times 1 over epsilon squared times modulus of u squared times 1 minus modulus of u squared minus 2 times, well, gradient, norm of gradient u squared. Now notice that this is minus v, so this is minus 2 times 1 over epsilon squared, that's modulus u squared times v minus 2 norm of gradient u squared. Now passing this term to the other side, obtain minus the plus v plus 2 times 1 over epsilon squared times modulus u squared times v is equal to minus 2 times gradient, the norm of the gradient of u squared. Now, here we're taking v as a variable here and u as fixed, as a fixed function. So now this is positive, 2 times 1 over epsilon squared times the modulus of u squared. So using the maximum principle, we have that the maximum is attained at the boundary, d omega. So we have the maximum and omega of v is the maximum on d omega of v. But we know that v in the boundary is 0, since the modulus of g is 1, and then this is 1, so v is 0. So that means that the maximum of v d omega is 0, which implies that the modulus of u is less than or equal to 1. So this is the solution of the problem.